Solutions. Solution is a homogeneous mixture of two or more pure components. It can be physically separated. Solution is composed of solutes and solvents. So what is solutes? Solutes are the substances that are being dissolved, while the solvents are the substance that dissolves the solute. So our universal solvent is water. Mixture. A mixture is a combination of two or more substances that do not combine chemically but remain the same individual substances. They can also be separated by physical means. So we have two types of mixture, the heterogeneous mixture and the homogeneous mixture. Heterogeneous mixture. Hetero means different. Heterogeneous mixture consists of visibly different substances or phases. So heterogeneous mixture also contains two or more ingredients or phases. This mixture can be separated by filtering. So an example for heterogeneous mixture is assorted gummy candy. So another example is oil in water. Homogeneous mixture. Homo means the same. It has the same uniform appearance and composition throughout. It maintains one phase. Homogeneous mixture is also commonly referred to as solution. So an example for this is a milkshake. Another example is chocolate and coffee. So classification of solutions. So we have solid, liquid, and gas. So in the picture we can see some examples. Solvent is the largest part of the solution and the solute is the smallest part of the solution. So below are the types of solution. We have the unsaturated solution, saturated solution, and supersaturated solution. Unsaturated solution means more solute are dissolved. Saturated solution means no more solute are dissolves. And supersaturated solution, it becomes unstable and crystal form. So how does a solution form? First, solvent molecules are attracted to the surface ions. Second, each ion is surrounded by solvent molecules. Third, enthalpy changes with each interaction broken or formed. As a solution forms, the solvent pulls solute particles apart and surrounds or solvates them. So what does solvates mean? Solvates is a compound that forms between a solute and its solvent. So we have two kinds of solution, dilute and concentrated. Dilute is a small amount of solute dispersed in solvent, meaning lasaw ni siya. Concentrated, a large amount of solute is dissolved in solvent, meaning espiso ni siya.
Types of solutions based on solute concentration. Hypotonic, lower solute concentration to the solution. Hypertonic, higher solute concentration to the solution. Isotonic solutions are equal in their solute concentrations. We say that they are isotonic to each other. Types of solutions. Isotonic solution. Iso is same, tonic is strength. Same concentration of solutes and solvent. Hypertonic solution. Hyper is more, tonic is strength. More solutes and less solvent. Hypotonic solution. Hypo is less, tonic is strength. Fewer solutes and more solvent. Solubility. The amount of solute that dissolves in a certain amount of a solvent at a given temperature and pressure to produce a saturated solution. Factors affecting solubility. Solubility of gas in liquid. First, the effect of temperature is different for the solubility of solid in liquid from that of the solubility of gases in liquids. A cold can of soda tastes quite differently after letting it stand open for a few hours and then drinking it up after. At high temperatures, the solubility of gas in liquids decreases because the gas molecules move faster and tend to escape. Since the carbon dioxide escapes, the soda becomes flat. The solubility of gas in liquid increases with a decrease in temperature and decreases with an increase in temperature. Solubility of solid in liquid. First, the solubility of solids increases with an increase in temperature for endothermic reactions while it decreases for exothermic reactions. A plus B plus heat is AB. Heat is needed to dissolve A and B. If temperature increases, more A will dissolve in B, and if temperature decreases, a lower amount of A will dissolve in B. AB, A plus B plus heat. Heat is given off or the temperature is lowered to drive the dissolution of A in B. Any increase in temperature decreases solubility and a decrease in temperature increases solubility. Effect of pressure. The solubility of solids in liquids are not affected by pressure. A change in pressure influences the solubility of gas in liquids. When pressure is increased, the molecules or ions come closer to each other and there are greater chances for interaction between the solute and the solvent. Solubility of gas in liquids increases with an increase in pressure. Henry's law, named in honor of William Henry, who conducted experiments on the solubility of gases in liquids. Bottled sodas are produced under reduced pressure. When the bottle is opened, the carbon dioxide escapes, which is indicated by bubbling, and the partial pressure of CO2 above the solution decreases. As the pressure drops, the solubility of CO2 in the solution decreases. If the bottle is left open for some time, all of the CO2 will completely escape and the taste of beverage becomes flat. Factors affecting solubility of solids. Temperature. Increased temperature causes solids to dissolve faster. Shaking. Shaking agitation causes solids to dissolve faster. Particle size. Smaller particles dissolve faster because they have more surface area. Note: increasing of the amount of solute does not increase the rate of dissolving.
Miscible versus immiscible. Miscible liquids can easily dissolve in one another, while immiscible liquids are not soluble in each other. One example of miscible liquid is water and alcohol, and immiscible liquid is oil and water. Polarity and dissolving. Chemists use the saying, like dissolves like. Polar solutes tend to dissolve in polar solvents, while nonpolar solutes tend to dissolve in nonpolar solvents. In immiscible liquid, oil is nonpolar while water is polar. Electrical properties of solution. Electrolytes are substances that dissociate or form ions when dissolved in water. Ionic compounds are salts completely ionized in water, and they are classified as strong electrolytes, and solutions containing strong electrolytes have ions present in them. Ionic compounds in their solid form do not have ions and such will not be able to conduct electricity. Compounds that only partially or slightly ionize in solution are classified as weak electrolytes. Nonpolar compounds do not ionize in solution and are called non-electrolytes with only molecules present in the solution. Strong electrolytes produce large quantities of free-moving aqueous ions, whereas weak electrolytes produce only small quantities of free-moving aqueous ions. Colligative properties of solution. The properties of a solution differ from that of pure solvent. Properties that solely depend on the number of particles of solute present but not on the kind and nature of solute are called colligative properties. The higher the solute, the higher concentrated it is. The lower the solute, the lower concentrated it is, and it is directly proportional. Since non-electrolyte solute does not ionize in solution, the number of solute particles will be less in a solution containing non-electrolyte solute than in a solution containing electrolyte solute. The effect of an electrolyte solute will be greater than a non-electrolyte solute in a solution. Boiling point elevation. The boiling point is the temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. If a liquid has high vapor pressure, molecules evaporate faster and takes the shorter time to equalize the vapor pressure of the liquid and the atmospheric pressure, making the boiling point low. The boiling point of pure water is 100 degrees Celsius, but seawater, however, does it boil at this temperature but a higher temperature. The burn caused by boiling syrup is more severe than a burn caused by boiling water because the boiling point of syrup is higher than that of pure water. This is because the interaction of solvent in a solution is greater than the interaction of solvent in a pure solvent or solute in a pure solute. In pure solvent, as the vapor pressure increases to liquid to gas, evaporation rate increases and the boiling point decreases, and it has a little amount of temperature. In solution, the vapor pressure decreases, the evaporation rate decreases, the boiling point increases, and vapor pressure increases, the evaporation rate increases, and the boiling point decreases. It is the difference between the boiling point of a solution and the boiling point of a pure solvent.
Freezing point depression. The freezing point of a substance is the temperature at which the solid and liquid coexist and their vapor pressure are the same. If a non-volatile solute is added to a solvent, the freezing point of a solvent is lowered and the reduction of the freezing point depends on the number of moles of solute presented. The effect of electrolytes as solutes is greater than non-electrolytes because electrolytes ionizes in solution and as such contain a greater number of particles. The greater the number of solute particles, the greater the effect on the reduction of the freezing point. So, molarity. What is molarity? Molarity is a concentration of a solution expressed in moles of solute per liter of solution. Molarity is a conversion factor for calculation. So how to find the molarity? First, molarity is equals to mass of solute over liters of solution. So this one is an example in finding the molarity. We go next to molality. Molality is a measure of number of moles of solute present in 1 kilograms of solvent. This contrasts with the definition of molarity, which is based on specified volume of solution. A commonly used unit for molality in chemistry is mole per kilogram. A solution of concentration, 1 mole per kilogram, is also sometimes denoted as 1 mole. So in finding molality, molality is equals to mass of solute over kilograms of solvent. So this one is an example. So mass by percent. Solutions can also be represented as percent of solute in a specific mass solution. For a solid dissolved in water, you use percent by mass, which is mass percent. So in finding, we have this solution. Percent by mass is equals to mass of solute over mass of solution times 100. For us to find the mass of solution, we have to add mass of solute plus mass of solvent. So this one is an example. So this would be our last slide, and I hope you learned something. And thank you for watching our presentation. That would be all. Thank you.